Hi friends, once again welcome back in our educational channel that is Precisely. Friends, in previous video lecture we had studied the concept of edge trigger and the types of edge trigger flip-flop, that is first positive edge trigger D flip-flop and second that is negative edge trigger D flip-flop. And in this video lecture we are going to study the next type of flip-flop, that is JK flip-flop. Now what is JK flip-flop and why JK flip-flops are used? First of all, why JK flip-flops are used? JK flip-flop is used to eliminate the drawback of Rs flip-flop. So what are the drawbacks of Rs flip-flop? The first drawback is that the Rs flip-flop using NAND gate, in case of Rs flip-flop using NAND gate, when both set and reset inputs are low, the forbidden state or race state appears. Means when both set and reset inputs are low, what is the output state? We are not able to predict that state, and this state is known as a forbidden state or a race state. So this input, that is a set and reset S and R, that is 0, may be always avoided. The second drawback is that each set or reset changes the state, that is from high to low or low to high. While the enable input is high, the correct latching occurs. The correct latching may not occur. Means the transition of proper state may not occur. And to remove these drawbacks, one more flip-flop is invented, that is designed, and this flip-flop is known as JK flip-flop. That is the use of JK flip-flop, that is to eliminate the drawback of Rs flip-flop, the JK flip-flop is used. Now what is JK flip-flop? JK flip-flop, in that JK flip-flop, J stand for Jack and K stand for Kilby. The Jack Kilby is the name of the scientist who invented this flip-flop, and it is invented in 1953. So in 1953, Jack Kilby invented the new flip-flop which removes the drawback, and this flip-flop is known as JK flip-flop. Now the logic diagram of JK flip-flop is going to display on your screen. From this diagram it is clear that JK flip-flop is basically Rs flip-flop. What is R and S? That is a reset and set state. So basically it is Rs flip-flop. So along with the Rs flip-flop, the two AND gates are used, and through these two AND gates, the input, that is the J and K inputs, are applied to set and reset terminals respectively. So J and K are the trigger inputs that is applied to these AND gates, and along with that trigger inputs, the two inputs are connected, and that is the outputs are fed back to the inputs. The inputs for upper AND gates are external trigger, that is a J input, and the complement of output, that is a Q complement, is connected. The complement of output, that is a Q bar or Q complement, is connected as another input for upper AND gate. So the inputs for first AND gate or upper AND gates are J and Q complement. Hence the output of upper AND gate is J Q complement. While the input for lower AND gates are K input, that is the external input, and the output is feedback to this terminal, to this gate, that is Q. So K and Q are the inputs for lower AND gates, whose outputs are now K, Q. So J, Q complement drives the set terminals of Rs flip-flop, and K, Q drives the reset terminals of Rs flip-flop. That is the logic diagram of JK flip-flop. So in that JK flip-flop, two AND gates are used, the external inputs are applied to these AND gates, and the outputs are fed back to these AND gates. That is the construction of JK flip-flop. Now the conditions, cases. The first case, that is when both J and K inputs are low. The first case, when both J is equal to K is equal to 0. So in this case, whatever may be the another input, that is the feedback, output feedback to the inputs. Whatever may be the feedbacks, the output of both these AND gates remain low. Because it is an AND gate, the output of AND gate remains low when one of the input is low. The output of AND gate becomes high only when the all inputs are high. In this case, both J and K inputs are low, so whatever may be the Q and Q complement, the output of upper AND gate remains low, output of lower AND gate remains low. That means the set input and reset inputs are at low level. So flip-flop remains in last state. It will not able to change its state. It remains in last state. Now the second case, that is j is equal to 0 and k is equal to 1. That is j is equal to 0 and k is equal to 1. So in this case, there are two possibilities. In this case, there are two possibilities. That is initially flip-flop is in set mode. If initially flip-flop is in set mode, so the output of flip-flops are now q is equal to 1 and q complement is 0. So outputs are q is equal to 1, q complements are 0. So the inputs for first AND gate, the input for first AND gates are 0, 0 because j input is low and q complement is low because flip-flop is in set mode. So q complement is 0. So the input for upper AND gates are 0, 0 while the inputs for lower AND gates are 1, 1 because k input is high and output, that is q, is also high. So the input for lower AND gates are 1, 1. Hence the output of lower AND gate goes to high level while the output of upper AND gate goes to low level. That means the set input now goes to low level and reset input goes to high level. That means the reset pulse is applied to the flip-flop and hence the flip-flop changes its state from high to low. Now the output of flip-flops are q is equal to 0 and q complement is 1. So flip-flop is in reset. The second state, if initially flip-flop is in reset mode. If initially flip-flop is in reset mode, that means output q is equal to 0 and q complement is 1. So that is initial state. So now the inputs for upper AND gates are 1, 0 or 0, 1 while the lower AND gates are also 1, 0. That means the output of both these AND gate goes to low level. So output of upper AND gate, that is set input, goes to low level. Output of lower AND gate, that is reset input, goes to low level. That means both set and reset inputs are at low level. So flip-flop remains in last state. And friends, in this case, what is the last state? That is a reset. So flip-flop remains in reset mode. So that means from this we can conclude that when j input is low and k input is high, the flip-flop is in reset mode. Flip-flop remains in reset mode or flip-flop goes into reset mode. That is second case. Now third case, that is j is equal to 1 and k is equal to 0. That is j is equal to 1 and k is equal to 0. Friends, in this case also there are two possibilities. What are the two possibilities? First, if initially flip-flop is in reset mode. If initially flip-flop is in reset mode, so q is equal to 0 and q complement is 1. It is in reset mode. So q output goes to low level and complement goes to high level. So q is equal to 0, q complement is equal to 1. So friend, in this case, the inputs applied to the first AND gates are 1, 1 because there is 1, flip-flop is in reset mode, so q complement is 1. So input for upper AND gates are 1, 1 while the inputs for lower AND gates are 0, 0. Hence the output of upper AND gate becomes 1 while the output of lower AND gate becomes 0. That means the set input is applied. The set input becomes high, reset input becomes low. So flip-flop now goes into set mode. The transition of state occurs and flip-flop now enters the set mode. So in this case, the outputs are now q is equal to 1 and q complement is 0. So flip-flop goes into set mode. Now second possibility is, that is if initially flip-flop is in set mode. If flip-flop is in set mode, so outputs are q is equal to 1 and q complement is 0. So now the inputs for upper AND gates are 0, 1 while the lower AND gates are 1, 0. The input for upper AND gates are 0, 1 because flip-flop is in set mode. So q complement is applied to upper AND gate. So the input for upper AND gates are 0, 1 while for lower AND gates are 1, 0. That means in this case the output of both these AND gate goes to low level. So friends, the set and reset inputs are at low level. So the flip-flop remains in last state. So what is the last state? What is the initial state? In this case, the initial state is a set. So the flip-flop remains in last state. So from this we can conclude that when j input is 1 and k input is low, the flip-flop goes into set mode or if it is in reset mode, the transition of state occurs and flip-flop enters the same mode. That is J is 1, K is 0, the output is Q is equal to 1, Q complement is 0. That is the third possibilities. That is a third case, J is 1, K is 0. Now friends, the last conditions, that is when both J and K inputs are 1. When both J and K inputs are 1, once again there are two possibilities. Suppose flip-flop is in set mode. Suppose initially flip-flop is in set mode, so the inputs for upper AND gates are 0, 1, but it is set mode, so Q complement is 0. So input for upper AND gates are 0, 1, while the inputs for lower AND gates are 1, 1, because K is 1. Flip-flop is in set mode, so Q that is high. So the input for lower AND gates are 1, 1. Hence, the reset pulse is applied. Output of lower AND gate becomes high. That is a reset input. So reset input goes to high level, while the set input goes to low level. So the output of state changes from high to low, because it is already in set mode. So output of flip-flop changes from 1 to low. So now the outputs are Q is equal to 0, Q complement is 1. So Q complement is a input that is applied to the upper AND gate. So now the input for upper AND gates are 1, 1. Inputs for lower AND gates are 0, 1. So in this case, the output of upper AND gate now becomes 1, while the output of lower AND gate becomes 0. That means the set pulse is applied. So due to set pulse, the flip-flop enters in the set mode, goes into the set mode. Hence output becomes Q is 1, Q complement 0. So now the input for upper AND gates are 0, 1, because that 0 reset input Q complement is applied to upper AND gate. So the input of upper AND gates are 1, 0, 1, while for lower AND gates are 1, 1. So output of lower AND gate is 1, upper AND gate is low. So lower AND gate gives a reset pulse to the Rs flip-flop. So due to which the flip-flop goes into reset mode. So outputs are now Q is equal to 0, Q complement is 1. So once again this input is fed back to the input terminus. From this, friends, from this it is clear that the output will not remain constant at any state. It changes its state between 1 and 0, 1 and 0. It will not remain constant. That means flip-flop will not remain in set mode or in reset mode. The transition of state occurs between set and reset, set and reset. And this condition is known as toggle condition. That means the output changes between 1 and 0. It continuously changes. So this state, this condition is known as toggle condition. And these toggle conditions, the flip-flop in toggle mode is widely used in counters. So this condition is known as toggle condition. So this is JK flip-flop, in which when both J and K inputs are low, the flip-flop remains in last state. It remains in initial state. The transition of state does not occur. When J is 0, K is 1, flip-flop enters into reset mode. So output becomes Q is equal to 0, Q complement is 1. That is reset mode. When J is 1, K is 0, flip-flop goes into set mode. Hence output becomes, that is Q is equal to 1, Q complement goes to low level. And when both J and K inputs are high, the output changes its state between high and 0. And this state or this condition is known as toggle condition. That is JK flip-flop. So friends, thanks for watching this video lecture. In next video lecture, we are going to study the clocked JK flip-flop and edge triggered JK flip-flop. So friends, keep watching these video lectures. Bye. Take care. See you again.